Experimental archaeology and traceological analysis of lapidary objects from the Great Temple of Tenochtitlan, Ancient Mexico, by Emiliano Melgar and Reina Solis, archaeologists from the Great Temple Museum of the National Institute of Anthropology and History in Mexico. In this presentation, we will show you the results of 17 years of research about the traceological analysis of lapidary objects from Tenochtitlan. The Mexica, more widely known as the Aztecs, were fearless warriors who conquered and dominated different regions of ancient Mexico, receiving tribute payments and practicing ritual sacrifice and decapitation of victims and enemies. The capital town of the Mexica was Tenochtitlan, built on a series of islets near the western edge of Lake Texcoco in the Basin of Mexico. The Mexica founded the city in AD 1325. Its centre was the Sacred Precinct, a walled-off square area which housed the principal buildings and the most important structure, the Great Temple, Templo Mayor. From the foundation of Tenochtitlan in AD 1325 until the arrival of the Spanish conquerors in AD 1520, the archaeologists identified 7 constructive stages at this large stepped pyramid. The Great Temple was their most famous cult centre, with a double staircase leading up to 2 twin shrines, one dedicated to Tlaloc, the rain god, and the other to Huitzilopochtli, the war god. These 2 gods represented the Mexica's most fundamental economic concerns, agriculture and tribute. Both aspects were reflected on the more than 100 offerings associated with the Great Temple. Inside them, the archaeologists recovered thousands of objects from different provenances and raw materials. These wealthy contexts include local crafts, goods from tributary regions, relics or artefacts belonging to cultures prior to the Mexica, and faunal remains from diverse ecosystems. This research problem about local or foreign origin of the goods from the offerings is common among the Tenochtitlan's assemblage. In the case of lapidary objects, they were divided on their morphology and aesthetics in the main Mesoamerican styles: Olmec, Mezcala, Teotihuacan, Mayan, Mixtec, and Mexica, among others. How can we study the ancient technology of the Mesoamerican lapidary styles? We need to take into account the analysis of raw materials and working tools, characterize the manufacturing traces, reconstitute the step-by-step production, identify the existence of craft specialists, evaluate the style and function of the objects, recognize the mechanisms of their circulation and distribution, and distinguish local from foreign technological styles. In this way, this research created a huge reference collection of modern rocks and minerals and acquired some standard certified reference materials for geochemical analysis. To obtain raw materials for experiments and reference assemblages, we performed sample surveys in different regions of Mexico, Guatemala, and the United States. The mineralogical characterization of these materials was carried out by electron microprobe, micro-Raman spectroscopy, thin section petrography, and X-ray diffraction, among others. Because the artefacts from Tenochtitlan came from offering contexts, we do not have any direct evidence of their production. To solve this research problem, we analysed their manufacturing marks and ancient technology through experimental archaeology. We founded a lapidary workshop in 2004, located in the Great Temple Museum, as part of a larger project titled Style and Technology of the Lapidary Objects in Ancient Mesoamerica. In this workshop, more than 700 experiments have been carried out, replicating the different types of modifications that can be seen in the pre-Columbian lapidary objects: cuts, abrasions, drilling holes, incisions, and finishes. For this purpose, we employed similar raw materials to those of the lapidary collections. Also, they were worked with tools and processes that, according to various sources of information, historical documents, archaeological contexts, and research proposals, were most probably used by pre-Hispanic groups. The selection of materials used in the laboratory experiments was designed to encompass a very great variety of rocks and abrasives, as well as bone utensils, spines, fibres, reeds, and skins. There is a record sheet for each experiment with the following information: the experiment identification number, consecutive, the name of the experiment, the objective, the materials used, specifying their characteristics and measures, the description of the procedures used, type and direction of movements, and the start and end time of the work. During each experiment, detailed photographic records were made from the outset, and the materials involved to the result or conclusion of the reproduced modification. In this way, the abrading experiments consisted of thinning or flattening the surfaces of the materials. This process was performed by rubbing the pieces of different raw materials on the diverse rocks, using a back and forth motion without abrasives, or by adding moistened abrasives during work. The cutting experiments were performed using flakes and blades, as well as abrasives with leather strips or vegetable fibres. In all cases, the tools were used in a back and forth motion. Drilling experiments were carried out with burins, spines, or abrasives. In all cases, alternating rotational movements were used. The incisions were made in the form of grooves that do not go beyond the edges of the pieces. To make them, sharp stone tools were used with a back and forth movement. The polishing and brightening experiments were performed with abrasives, pebbles, and leather. After each experiment, the reproduced pieces were observed and compared with the archaeological objects. These comparisons were made with the following levels: macroscopy with loupe, optical microscopy, OM, and scanning electron microscopy, SEM. Because the moving of materials to SEM labs from the museums or storerooms require special permits, we employed a technique to produce replicas in polymers softened with a drop of acetone for seconds. The film is pressed immediately onto the zones of the objects to be analysed, obtaining a perfect mould on the polymer tape in 1 minute or less. Later, these moulds were covered with gold ions for their observation at the SEM lab in a high vacuum mode, which permits a greater image resolution. The replication method avoids having to move the archaeological materials because the polymer samples are produced in the repositories where the original material is kept. It also facilitates work sessions because up to 20 moulds can be examined in 2 hours. Finally, it is possible to examine pieces that will not fit into the microscope's sample chamber. The employment of optical microscopy allows us to identify and distinguish the use of lithic tools against abrasives. However, it is also evident that with this level of observation, it is not possible to discern between the marks left by similar tools made of different materials, like obsidian or chert instruments at edges. In contrast, the scanning electron microscopy permits a greater characterization of the manufacturing traces. This way, each experimental and archaeological modification was compared. We replicated specific pieces with the identified ancient technology. We also compared the manufacturing traces among pre-Hispanic pieces to evaluate if they shared the same technological style. We could detect specific local or foreign chaîne operateurs based in a traceological analysis of lapidary assemblages from different styles, and from more than 80 pre-Hispanic sites located in Mexico, Guatemala, United States and Costa Rica. Following this methodology, we identified new lapidary styles in Tenochtitlan, like Zapotec, Huastec, Xochicalcan and Toltec pieces. We also detected new relics, Teotihuacan inlays and pendants, Olmec axes and beads, and Mayan plaques and beads. This new style and relics could be obtained by the Mexica through special gifts, war prizes, tribute payments, and looting ruins. Another interesting result is the Imperial Tenochtitlan style, presented in different raw materials: obsidian, travertine, turquoise, serpentine, and jadeite, and objects, mosaics, sceptres, sculptures, and beads. Some of them had the same shape, size, techniques, and iconographic decoration in different materials, known as skeuomorphism. Perhaps these objects were crafted by the skilled artisans of the palace workshops under the control of the Tenochtitlan rulers and priests, as reported in the written sources, whose ritual goods were restricted to the feasts and offerings of the sacred precinct. The local and exclusive production of these goods was appreciated even in the common jewellery found at Tenochtitlan, like labrets and duck head pendants, because they are different in shape and raw material in comparison with similar pieces from other sites of the Basin of Mexico. Conclusions. Not all the foreign raw materials in Tenochtitlan came as finished products. Some of them were crafted at the local lapidary workshops in the city. The characterization of manufacturing marks with experimental archaeology, combined with OM and SEM, improves the accuracy of the tools identified. The different technological patterns among lapidary assemblages enhance the characterization of particular craft styles. There are two main groups of results. First, we identified new foreign manufactures and unreported styles and relics, like Zapotec, Mayan, Xochicalcan, and Huastec pieces. Second, the Imperial Tenochtitlan style includes a huge number of objects in different raw materials with a great morphological and technological standardization, reinforcing its local production at the palace workshops by dependent artisans of the Tenochtitlan government. Finally, we hope that in the future, further analysis of this type will be conducted to regionally characterise diverse traditions and lapidary styles in order to shed greater light on the relations and interactions among different pre-Hispanic groups and cultures. This research would not have been possible without the collaboration and participation of different colleagues and institutions. Thank you.